Now we've got this out, we can get us a better access to our condenser. Now if you notice here, this is our condenser. Put a little light on it, and you'll notice that is our liquid line down here. This is compressed freon. As it goes down and cools down, it turns into a liquid at the bottom. Now I like to look, if you look, you don't see no oil, so that's a good sign that our condenser is not have any kind of leak. Like I said, compressed freon goes in there, liquid freon comes out there, ends up through this line up to here, and it's still a liquid line. So we're still liquid. We don't turn into a gas till past the orifice tube here, and then it starts the expansion process and goes into our evaporator, cools the air or pulls the heat from the air. This is our dryer. After it comes out of there, what it does is there's any trash, and when we call it a dryer, what it does is takes any moisture out of the freon in case there is some moisture in there. We know our culprit is right here. This is where our leak is. What I done is I took and put the gauges on it last year, and these valves are bad about going bad. Once you open them up, it's hard not to leak. All right, let's get started. While we're in here, we'll take a look. Right there is our power steering cooler. So our power steering fluid is cooled down as well here. So they got a lot of stuff going on underneath here. If you look and see how dirty this is, you would think that traveling in the rain, and we've got a big ass gap hole right there. That comes from a rock that's been bounced up off a highway. I don't see any oil around it. With no oil around it, I don't think we got anything to worry about it. But we'll put the glasses on it and look and see. Just to make it a little easier on me, I'm going to remove these 4 13s and get this little brace out. Now this last one's going to let it drop. That way I have a little more access to our liquid line. Now this liquid line, what it does is it carries up liquid freon. The expansion valve slows it down, and this turns into a suction coming from the compressor and causes the gas to expand, which turns cold. Now we can we've got a lot better access. Only 4 more bolts gives us a little cleaner job. My hope is when I break this loose, I'll be able to slide this back without taking it loose. Every time you break a connection, you really need to replace the O-ring if you can get one. I don't have one. We'll see how this is going to turn out. I may make a bigger mess than I started out with. I'm going to put on some gloves too, because I don't want that freon oil all over my hands. Here I got some of the finest Pittsburgh steel you can get, but it's a 19 and a 22. Now here, of course, we want to take it easy. We don't want to bend or break our lines, or twist them for that matter. Now I will work this back and forth a little, just to make sure I don't have any corrosion in there, because we're going to have to reuse this. If we don't, we're going to have to buy one. I don't want to buy one. Now, be sure not to put pliers on this. The thing is this is aluminum as well. And smashing it together makes it hard to come apart, because this is going to be steel, this is going to be aluminum. Let's get a magnet and I'll show you. And anytime you put aluminum and steel together, you get a corrosion. And of course the changing of the metal too, that aluminum will warp. Like I say, I'm gonna work it back and forth. We don't want to spend more money. And this part is not absolutely necessary, but it's empty, and I thought I'd show you how to replace your orifice tube. And we'll get to look in there and find out if there's a bunch of trash or anything that has accumulated in that, which will be coming from the compressor side, be part of the reed valves. Now, don't forget, this is completely empty. If you look here, that's out, that line is open. This is what we're going to replace. I just got it sitting up there actually to make sure that nothing else gets in there. All right. And I have noticed that there's a bit of trash falling out of that. Like I said, work it back and forth, kind of clean up your threads as you go. You can see trash or parts of materials falling out of that, because the threads on that steel, you can see in there corrosion. You can hear it listed. You see all the crap falling out of that? And that's corrosion between the two different metals not being the same. Now so look there, it's already broke open. Now I'm going to finesse it. I'm going to try to finesse it and bend it just a little to pull it off here without taking it apart anywhere else. There's our O-ring. Now we're going to have an orifice tube up inside there. Now orifice tube should be up inside there, and we'll see if we can get it pulled out. Now this is our orifice tube, the new one. We're going to put in there, and the tool works pretty simple. It goes in, and there's several different designs, but it goes in. When it turns, it hooks that. Then you screw this portion in up against the line, and it kind of presses it out or pulls it out. So we'll see how good it works on this. Okay, I'm going to turn it till it wants to slide in and out. If it ain't hooked, we're not in the right spot. Now in order to do this, you're going to have find it best to wiggle this back and forth till you feel it lock in, and then you have a good hold on it. Now if you notice, the oil looks nasty on it, but I don't see anything wrong with the orifice tube on this. But we're going to put a new one in there anyway. I don't know how much wire you can get on the orifice tube, but let's... Now depending on how these are, where they're mounted, sometimes this end is on this end, so you want to make sure that they're the same, because there's several different ones. Ford uses them too, so there's several different types. So just make sure you got the same one that's matching up. Now we're going to want to put a little AC oil on this, on the O-ring. Don't take a lot, and there's probably plenty of oil still left inside the unit anyway. Now, it came out, they go back the same way. I'm gonna wiggle it a little, push her in until she stops. Now let's see if we can find us an O-ring. Now I found me a pretty good match. If you look, that's kind of misshaped. So I definitely want to put a new O-ring on that. I want to make sure that I got a good clean mating surface as well, because typically what it's going to do is when it pushes up against it, it's going to flare into the inside of this and give us a good seal. Been easy not to cut my O-ring. Now I'm going to add some AC oil. Now you want to use the proper AC oil too, because the 134 freon is different than the newer style, but and then that way it doesn't eat up your O-rings. I'm as well going to do the same thing, clean the inside of this up. Make sure there's no debris that came out of that where these two met. Now that looks pretty clean. Now I've got me a little oil. I want to make sure that's coated good. And I'm also going to coat these threads with it. Put me a little bit there. Hopefully all difference. Now we'll see if we can't put her back together. Now I should be able to do this by hand now, and by not bending a lot of this, I didn't change the shape of the tube. And the bad thing is with that aluminum nut, and I'm going to tell you right now, just by breaking it loose, it's oval shaped. And I'm going to ease that back up there, and I'm going to go until I feel a little restriction on it, and then I will bring my other wrench, because I don't want the line to twist back and forth while you're doing this. That's more of a chance to cut our O-ring. We want them both to be pulled simultaneously. So I'm going to hold that one until she locks down, because we want our tube to be, or our liquid line to be, as much in line as it can possibly be. So if it's offside one side or another, it could cause that O-ring to be pinched on one side and not. Now it don't take a lot, because all you're doing is getting your seat between the O-ring, so it'll crush the O-ring down in there and seal it up. Now it's on to our high pressure valve. The new one has just a little Loctite on it. I don't know how I feel about that. We also want to make sure our inside is clean. Free of debris. I got a little extra oil on me. Okay, I think we're ready to install it. Now here's the deal with this, is they don't want you to, they make a special tool for this. You see that O-ring's going down in there to seal a gap. These don't have to be tremendously tight because the O-ring does all the work. So I'm just going to take me a pair of hose pliers here and snug it a little more. There, that's all we need. It's not going to come off. But first, we'll do a vacuum. We'll do about a 15-minute vacuum, and then do a 15-minute set to make sure we've got no leaks. Then we can move on to add some freon. We are coming down on a vacuum, so we'll let that run for about 15-20 minutes. Make sure we got a good vacuum. The longer this vacuum pump runs, the drier that the air is inside, and we want it as dry as we can, because freon and moisture, when they mix together, it's going to automatically freeze. And when you have small ports like inside your evaporator, it'll freeze, and then that just blocks off that area. You get a high pressure shut off, could blow a line, cook a compressor, so we don't want that. Now we see here, with this hooked up, that switch is open, so we got a 10-volt voltage drop. This circuit goes through a resistor, so our system voltage is approximately 12 volts. It's dropped down to 10 volts. So once a freon, we start filling up with freon, that switch will close. This should go near zero. So that's our next look, and I'll show you what happens. I'm gonna let my scale settle down. We haven't added any freon. We've been holding 29 inches of vacuum, which will boil water. We're going to zero this out. Now that we know we have no freon in it, I'll show you over here. Notice our voltage is starting to drop. What we may do is just go ahead and start our engine, and that way we don't get our voltage too low. But what I will show you, I'm going to go ahead and add some freon to it. I'm going to add freon to it, and you'll actually hear this thing click as the freon goes in. Watch that when it clicks. See what happened? We went to zero voltage. Switch is good. We have freon in it. We'll put about a half a pound in it. Now this system holds somewhere around 1.8 pounds. Now we can start the truck, turn the AC on, and we'll bring her on up. Now I haven't turned on my AC yet, but you'll notice the same thing when that clicked, closed our valve here. We haven't commanded anything on yet, so once I AC request, that should go yes. Relay should go on. Okay. Now we're going to find out if the AC did request on. AC request yes. Our cycling switch is interrupting our flow, so I can show you on that. If you'll watch your cycling switch. That cycling switch closed again. Now the logic is why it didn't just automatically, as soon as the cycling switch says there's not enough freon in it, they don't want to damage your system. See how it went to open? It'll go to closed. It allows it some time for it to before it just re-engages it, just in case there's another issue, so it don't just jump right in there and do it. Our high pressure is still open. That's high pressure shut off in case it's over pressurized. Now I know this thing holds 1.5 pounds, but we're gonna get her on up there. And if you'll notice, the more freon, the longer the cycle holds out. Now I am putting it in as a liquid, so I do not want to overstress my compressor. See how much longer it stayed in? Compressor is making a little noise now. Now we're at 11, so we're nowhere near what we need to be. You'll notice I'm putting a liquid in on this side, but it's going through just as if this is a liquid up to here. See, now our compressor starts to stay on longer, so we know we're getting closer to actually having the right amount of freon in there. We're at 30, which is saying that the evaporator is at 30 degrees. It's close. Our air is nice and cold. Now what I'm gonna do is I want to bring it on up, and you got to think about the temperature in here. Temperature in here is around 70 degrees. Now I'm not monitoring my high side for the simple fact, and if you'll notice, look at our pressure. Now the air traveling through there is around 40 degrees, 38 degrees. Because the GM valves, they'll get oval shape, and it takes a little while for them to actually retain their shape. And I have a macro set of gauges, and they just push right on. And when that happens, when you push that right on, it shoves that valve down and really distorts the valve on the GM. It does fine on any of the rest of them, but that GM valve, to me, I don't understand it. Now see, we're at 1.2 pounds. We're close to what we need to be. We have no cycling going on. We're running about 40 degrees in our evaporator. Now 40 degrees evaporator is not necessarily 40 degrees in your vehicle. Or it's not 40 degrees in your vehicle. Everybody's happy here. Yes, on, closed, open. If this one goes to high pressure, it'll shut it off. It's tested the same way. Good thing about it, it's tested the same way. I showed you how to test it earlier. That's the high pressure. Now, the high pressure is in line with the compressor. The compressor, if it sees a high pressure reading here, it'll shut it off to keep from damaging our compressor. Now let's take our thermal gun and take another look at what's going on here. Now I told you that was the liquid line. Our liquid line is running about, on the liquid side, we're running about 85, 87 degrees. You notice the more the gas expands, the lower the temperature. Now right here we're at 63 degrees. Now we're at 72. If you notice this is warmer than this, that's because all the expansion is occurring inside the evaporator. and the air is actually where it's absorbing the heat. It shows up here. And that's what we want. See if we can pick up some. See if you'll notice here, this is pretty cool too. We're at 115 degrees, 119 degrees. Now, if you get a strange reading, $95, 105, 96, 87. The further down you go, I'm thinking, see, if you think about this, think about it this way. The lower portion of this condenser is actually liquid. The compressor starts out, dumps it in the top, starts compressing at the top, and then as the liquid compresses, as the gas compresses to a liquid, then it forms at the bottom, and then it takes it back. If you look there, now we're starting to get a good, nice little condensing going on. There's our hose section. Our evaporator hose. Good little water flow there, tells us that we're not stopped up. Now if we can take our heat gun, we'll see what our vents is actually putting out. Oh, it feels nice. See if this will show what kind of temperature our vents is putting out. 54 degrees there. It smells good in here. So they're pretty consistent. So the air is around 54 degrees coming through it. I think it's very nice. And because of the temperature of the day and the heat, I believe we're pretty close to what we want to be. The thing is people want to add oil. If you add an ounce of oil, you take away an ounce of freon. What does the cooling? Freon. Now the oil will take, and that's what your compressor is actually lubricated, because it flows through. The oil is always flowing through as a mist and keeps the compressor lubricated. The compressor is going to have some stored in it, but it's not going to be a huge amount. Now because I've got my windows rolled down, now if I'll roll my windows up, put it on recycle, but you got to think of this too. Now right now it's pulling in freon, or pulling in the heat from this engine through the evaporator. Now we'll roll my windows up, we'll watch. You'll see as this will start coming down, because the cabin temperature is also coming down. Now you would think the more freon that you put in a vehicle, the cooler it'd be. Now you got a magic number. All right, we'll take this to recycle. Now that way it's pulling in. Recycle there. We'll be able to see our numbers start to drop, and they'll probably do it pretty quick too, because we're not pulling in air from our engine. See, we're already down to 40, and it'll continue to drop down. All right, now I know I put 1.1 or 1 pound and 12 ounces. That's getting close to our 1 pound 15 ounce. Now I was saying before, cabin is cooling down, so our actual evaporator temperature is cooling down as well. All right, we was running what, 54? Let's see what our vents is actually showing now. And it's just like anything else. The cooler the house gets, the more the cooling system works. Now we are nice in here. Let's see what we got. Oh, look at there. 41 degrees. From 54 to 41. 39 over here. 38. So our actual temperature, air temperature is around 37 degrees. Very nice. Now we're down to about 30 degrees. Notice that's coming down there. That's down to 56. Now 56 degrees is how much temperature has come down inside here. .38 degrees. So our evap temperature, according to our low pressure side, the evap is actually running 30 degrees. Starting to fog up in here. I think we're done. Now what I want to do first though is I've got to disconnect my low side. So even after me just opening that door, the temperature inside the cabin has gone up 2 degrees. Now you hear that hissing sound? That's coming from the liquid freon expanding into this section.